Hello students, in this video we're going to talk about conjugate numbers. So at the end of this lesson you should be able to multiply imaginary numbers using conjugates. So let's get started. First thing we want to talk about is letting z be a complex number. Now z is a complex number because it contains real numbers a and an imaginary number b or bi. So that's why they're called complex numbers, because they have a real number and an imaginary number. So note that each complex number, though, has a conjugate. A conjugate means it comes with a pair. It comes in pairs. So if you have z, and we're saying z is equal to a plus bi, then z, the complement of z, marked with this line above the z, it's called let z complement represent the conjugate of z. So basically what they're saying is, if z is equal to a plus bi, then its conjugate is a minus bi. So another example is if we said z is equal to 3 plus 4i, then the conjugate is going to be 3 minus 4i. So notice there that the only thing that changes is the part that's attached to the imaginary number to the I. So let's look at a few conjugates. Now if z is equal to 2 minus 3i, then if we look at example 1, we're looking for the conjugate. So then the conjugate of z minus 2i would be 2 plus 3i. And the conjugate for y is if y is equal to 4 plus I, then its conjugate is going to be 4 minus I. It's not too bad. Now let's look at an example. If we were to multiply z and its complement or its conjugate, it would be 2 minus 3i times the quantity 2 plus 3i. If we FOIL that out, that's going to be 2 times 2, 2 times 3i, negative 3i times 2, and negative 3i times positive 3i. We're left with 4 plus 6i minus 6i minus 9i squared. If we simplify that further, we get 4. You'll notice that the 6i's canceled out, and then you have negative 9, and then the I squared is equal to negative 1. So that actually turns into 4 plus 9, because negative 9 times negative 1 is positive 9, and 4 plus 9 is 13. So let's look at y and y complement. So if we look at y and its complement, we get 4 plus I times the quantity 4 minus I. Again, we FOIL that out, and we get 4 times 4 is 16, 4 times negative I is negative 4i, I times 4 is 4i, and I times negative I is negative I squared. Again, we simplify that out. That means the negative 4i and the positive 4i cancel each other out, and you're left with 16 minus, and the I squared is negative 1. You're left with 16 plus 1, and that's 17. So let's try applying this to something a little bit spicier. We have example 4, where we're going to rationalize. So we did this a few chapters back. And what we're trying to do here is we're trying to make sure that the denominator doesn't have an I. So in order for us to do that, we need to multiply by the conjugate. So since we're trying to get rid of the I on the bottom, on the denominator, we're going to multiply by that conjugate. So the conjugate of 1 plus I is 1 minus I. And we're going to multiply that to both the top and the bottom of our fraction. And that would look a little bit like this when we multiply. Now what we're going to do is we are slowly going to FOIL that out. So when you FOIL the numerator, this is what you get. You get 11 times 1 is 11, 11 times negative I is negative 11I, negative 3i times 1 is negative 3i, and negative 3i times negative I is positive 3i squared. The bottom, we do the same exact thing. Then we're going to combine like terms on the numerator. Negative 11i minus 3i is negative 14i. And when we do the same thing at the bottom, negative I plus I cancels out. And keep in mind that I squared is negative 1. So negative 1 is positive 1 like we see here. So we combine those and we get 11 minus 14i minus 3, all divided by 2. We combine like terms again. 11 minus 3 is 8, minus 14i, all divided by 2. And because we are putting this in the form a plus bi, we have to separate these things. So what actually happens here is that you get 8 divided by 2 minus 14i divided by 2. So 8 divided by 2 is 4, and 14 divided by 2 is 7, so negative 7i. Let's look at the next example. 4 plus I all divided by 2 minus I. The conjugate that we're multiplying by should be 2 plus I. So now that we do that, we're going to rewrite it so you see what we're multiplying. Then we're going to FOIL that out. We're going to simplify again. So 8 plus I squared, because I squared is negative 1. That's why we get 8 minus 1. And then 4i plus 2i is 6i. You'll notice on the denominators, 2i minus 2i cancel out. Negative I squared is negative 1. And then when we add these things up, 8 minus 1 is 7, plus 6i, and then we have 4 minus 1, which is 5. And now we have to make that in the form of a plus bi. So, just like we did in the last problem, we have 7/5 plus 6i divided by 5. Notice that we're just taking that denominator and dividing it to each piece individually. So your a plus bi form is actually done. It should just be 7/5 plus 6i divided by 5. And that's it. Now it's your turn. Try these 3 problems, and we'll take a look at them tomorrow in class. That's all for now. I'll see you guys next time.